Hi, today we're going to be talking about power and torque. This is a topic that confuses a lot of people, even though there are tons of publications and articles online. And I think this is because we often try to understand it backwards. When we hear power and torque, we often imagine some sort of machinery, cars, engines, electrical motors, and we're trying to make sense of what the power and torque are through that, but sometimes it only confuses us even more. Take a look at these two engine specs, for example. Which one do you think is more powerful? It sounds like a tricky question, isn't it? Because engine on the left has 340 kilowatts of power and engine on the right has 294 kilowatts of power. So the engine on the right is less powerful. The only one thing that still may be a little bit confusing is why is that less powerful engine has greater torque? Okay, let's put aside all those engines and cars and try to figure out what's the difference between power and torque and how they're related as well.
Okay, let's start with torque first. So here we have two spinning cylinders. This is a top view or maybe shafts or whatever they are. Let's say we have two cylinders here. So they're exactly the same. They're made of the same material, they have exactly the same dimensions, everything is exactly the same. And they slowly spinning with the same speed. So I put 6 here. They're spinning with a speed of 6 revolutions per minute. Very slow rotation. So as I said, everything is exactly the same. But if I place my hand on this one here, I will easily stop it. Same way I stop this small DC motor here. However, if I try to stop this one here, it will still keep spinning, like nothing happened to it. It doesn't matter how hard I'm trying to stop it, it's just gonna twist my hand, so I have to let it go. It's not spinning faster than that one here. Same slow speed, exactly the same rotation. Maybe it's connected to a bigger motor or whatever. We don't know, it's a thought experiment. So what we can tell for sure is that this shaft is more torquey, so it has greater torque. It's probably maybe also more powerful, but let's just stick with torque for a moment. But what the torque is? Torque by itself, it's not a time-based, not a time-related value. Just another little experiment here. So here we have two spanners, and what we're trying to do is we're trying to torque that bolt here up to 10 Newton meters. We can use, let's say this spanner is 1 meter long. So we have 1 meter long spanner, and we're pushing here with the force of 10 newtons, which is about roughly 1 kilo. So we're pushing here with 10 newtons. And if we assume that this spanner is 1 meter long, we can say that we're torquing that bolt, we're tightening it to 10 Newton meters. But what if we want to torque it up to 20 Newton meters? So, well, we can push at that point here with the force of 20 newtons and torque it up to 20 Newton meters. Or, another way to do it is just use twice longer spanner and using the same force. So to torque that bolt to 20 Newton meters, we can push here with 20 newtons on 1 meter long spanner, or use 2 meter long spanner and push it with the same force, 10 Newton meters. And we're gonna torque it, because we're gonna multiply torque, we're gonna torque it up to 20 Newton meters. But we can torque it very slowly or a little bit faster or slower, it's still gonna be same 20 Newton meters. And we're encountering that torque multiplications every time in our life without even without even realizing it. So for example, this is where we hold spanner as far as possible from the bolt, because it's much more easier to tighten the bolt. And for the same reason, door handles located where they are, at the edge of the door, not in the middle or next to the hinge. I set up a little device here. I hope it will help you to understand how torque reduction and multiplication works. So it consists of 5 sprockets, and every single sprocket is 5 times smaller than the sprocket before it. So if I will rotate the first one 5 times, then the next one, the second one, is going to make only 1 revolution. And when we drive the whole thing with tiny DC motors, so what's happening here is the motor has about 2 Newton meters of torque, so the next gear is going to have 10 Newton meters of torque, because it's spinning 5 times slower, so it's going to have 5 times more torque. There's obviously
obviously some friction happening, and they have mass and they have a moment of inertia and so on, but we're not going to take it into account here. So the third one is going to spin again 5 times slower than the second one, so it will result in 50 newton meters of torque, and the gear next to it is going to have 250 newton meters, and the last one will have 1250 newton meters, which is crazy torque, right? But here's a catch: we can multiply torque, but we cannot multiply power. That's why the last gear is gonna spin ridiculously slowly. In fact, if we're gonna spin the first one, let's say 125 revolutions per minute, so the second one is gonna have 25 revolutions a minute, the third one 5, the fourth 1, and the last one is going to make only 1/5 of the revolution in a minute. And this is because we cannot multiply power. Even though the torque is going to be so much higher, the speed is going to be as lower, and thus the produced power is going to be exactly the same as on the first gear. So the power is a time-based value. It depends how fast we doing something, how fast something is happening. And the last one for today, just to confirm our understanding. So here we have again 2 wheels or gears. Let's say those are gears, and they connected to different engines or transmissions, though they're not related to each other. So which one do you think produces more power? And I encourage you to pause the video and to tackle it on your own. Okay, I assume you paused the video and gave it a shot. And now let's try to figure out together. Well, there are a few ways to tackle that problem. The simplest one probably just to use the mathematical formula, but we can also use our imagination, and we will try to connect to those gears in other gears to equalize the amount of RPM and see what's going to happen with torque. So what we're doing here is we connect into that gear here, we connect it in another gear which is 3 times bigger, and what's going to happen with RPM is going to spin 3 times slower. So we had 30 RPM and now we're going to have 10 RPM. But what's going to happen with torque is going to happen, it will be 3 times bigger. So 8 multiplied by 3 is going to give us 24. So we have 10 RPM and 24 Newton meters of torque. And the gear on the right, it has 20 RPM and 11 Newton meters of torque. To that gear we're going to connect another gear which is 2 times bigger, and because it's 2 times bigger, it's going to spin 2 times slower. So 20 RPM will convert into 10 RPM, and exactly opposite is going to happen with torque. 11 Newton meters will turn into 22 Newton meters. And look what kind of interesting situation we have here. We have 2 gears, they spin, they're different in size, but it doesn't matter because they both spin at the same RPM but with different torque. One has 24 Newton meters of torque and another 22 Newton meters of torque. And if we imagine that we connected some sort of shafts in the middle, both of them gonna spin with exactly the same speed but with different torque. And that proves that this gear here is producing more power. And that was the last part of today's video. I hope you found that explanation simple, and I see you next time.